morning, ladies and gentlemen. It is my great honor to serve as the moderator for today's symposium. My name is Kyung-ha Kim, and I'm a senior researcher at the Institute for Future Strategy at Seoul National University. I would like to extend my deepest gratitude and welcome to everyone here for joining us today. Today's symposium is centered on the theme, Global Energy Policies and Sustainable Innovation. In the face of a rapidly evolving energy landscape, this gathering offers a critical platform to exchange global strategies and explore innovative solutions to build a sustainable future for the energy industry. I would like to extend our sincere gratitude to the Honorable Mark Menezes, who has generously taken the time to be with us and will share his invaluable insights during today's keynote presentation. Mr. Menezes is currently the President and CEO of the United States Energy Association, representing over 150 member organizations across the U.S. energy sector. Previously, he served as the Deputy Secretary of the U.S. Department of Energy, where he did strengthen energy security, drive technological innovation, and promote sustainable development. Before we proceed the keynote presentation, I'm delighted to introduce first Professor Joon-gi Kim, who is the Director of the Institute for Future Strategy. Ladies and gentlemen, please help me welcome the Director Joon-gi Kim to the stage with a warm round of applause.
소개를 다 하셨는데 잠깐 우리 Mr. Mark Menezes 다시 한번 소개해드리겠습니다. The Honorable Mark Menezes is President and Chief Executive of the U.S. Energy Association. As Kyung-ha said, he represents the broad interest of the U.S. energy industry and interacts with domestic and international leaders to advance knowledge and seek partnerships to develop and enhance energy infrastructure worldwide. Prior to his current role, he was the Deputy Secretary of the U.S. Department of Energy, and in his role, he served as the Chief Operating Officer over an agency with 120,000 employees and contractors, and a $34 billion budget, and management responsibilities of the 17 national labs, the nation's nuclear weapons programs, and its environmental cleanup obligations from the Manhattan Project. He's also currently adjunct professor at Georgetown, and he's also the founder of Global Sustainable Energy Advisors, LLC, a strategic advisory firm to energy and technology, as well as defense organizations around the world. Please join me in welcoming Mr. Mark Menezes. Thank you.
Well, thank you very much, Dr. Kim, for that really warm introduction. And it is indeed an honor and privilege for me to be here at Seoul National University. I've learned a lot about Seoul National University, particularly with my association of my brother-in-law, Dr. Sang-gu Lee, whom I certainly understand the role that Seoul National plays in developing policies, and of course the leading institution of Seoul. So it is really, the warm welcome is very meaningful to me. And thank you, Sang-gu, for helping arrange this, as well as you, Dr. Kim, and Dr. Lee. Also, I'd like to also introduce my young Nim, Sang-wan Lee, who joins us this morning. And of course, the main reason that I am here is because of my wonderful wife, Dr. Yun-Hyung Lee, who works at the U.S. State Department. And so they have joined me this morning to listen to our conversation. So welcome, family, and thank you all very much for making us feel welcome. So I'd like this morning's talk, really, to be a conversation. I will make some presentation on some of the trends that I see globally and in the United States with respect to energy. I'll talk a little bit about what the United States Energy Association is, but I'll then talk in terms of what we see globally, both with energy demands and with emission reductions. We live in a world today where climate change goes hand in hand with energy policy and environmental policy, and it's at that nexus where we're going to talk about some of these issues today. Now, before I begin, I do need to make sure that everyone understands that what you hear today really are my own opinions and thoughts. I'm not really representing or speaking on behalf of the United States Energy Association or its members or its board. And similarly, I'm not speaking on behalf of the U.S. Administration, either the current or the future administration. So these are really my thoughts and my observations and should not be attributable to anyone other than me. But before I begin, I know that we have quite a group of interesting people here, experts, some are students, but I'm curious how many in the room are business students, graduate students in the administrative, if you're doing administrative policy law. I mean, in that field of study. Policy? It's okay. You can raise your hand. How about business people? Okay. And then is everyone else just students or passersby? Okay. Well, again, I want this to be a conversation. I want you to feel free to ask questions. So with that, I think I'll begin. Tell you a little bit about what the United States Energy Association is. We are a not-for-profit. We're not a trade association. And so we convene and educate policymakers, the public, the press. We're nonpartisan. We look to help develop energy policy, both in the United States and internationally. We are 100 years old this year. The United States Energy Association got its beginnings as the U.S. member to the World Energy Council that was formed 100 years ago to foster the mission of bringing accessible and affordable energy all across the world. And that mission continues today. So we work with the United States government, particularly the United States Agency for International Development in the developing countries, to bring access, affordable energy, also energy independence. In addition to the developing countries, we work in Eastern Europe, for example, to help bring independence to those former countries that were part of the Soviet Union, for example. We were in the Ukraine and helped the Ukrainians disconnect their electricity system from the Russian electricity system as we saw the buildup before the invasion. Successfully was able to disconnect the Ukrainian electric system from Russia. And so Putin was unable to shut down the electric system of the Ukrainians. And in a matter of 3 weeks, was able to get that grid interconnected into the EU grid system. So that's an example of some of the things that USEA is capable of doing and does. We also work with the State Department in strategic places around the world, again, ensuring reliable, affordable access to energy. And also we work with the Department of Energy in furthering different advanced technologies as we all develop technologies to bring about more efficient energy uses as well as new sources of energy. Again, with the drive primarily to do things more efficiently, and if we can, we have to reduce emissions. So it's quite an exciting organization. I'm really thrilled to be part of it. And we span 6 continents. Our staffs speak at least 14 different languages. And I mentioned the work that we do with some of the United States government's agencies. Now, I want to set the table here for what we deal with when we try to address energy issues and climate change. And the place to start, when you recognize about climate change, it is a global issue. It's no one country's issue. No one country can reduce emissions through any set of policies and have a real impact on the emissions globally. So I like to remind people that typically the demand for energy has been with increased populations and economies around the world growing their prosperity, raising the standards of living for their people. These are the goals of any country. And with increased populations, with rising economies, emissions typically follow. So if you look at where the world is today, so today we have the population density is really in the developing countries. We know what that demand looks like. It's the developing countries that really have been doing a lot of the emissions. What you see is you have the OECD countries, North America. You see our friends and allies in Asia that are taking efforts to try to reduce their emissions. Their populations essentially are not growing. I saw a stat the other day that the world reached its peak on birth rate. The globe reached its peak in birth rate in 2017. We have had declining birth rates globally since that day. Now, looking forward, however, you will see that while we have about 8 billion people today, we expect the world to have an additional billion people by about 2037, according to the UN. Looking out a little bit farther, when some of the countries have announced reaching their net zero goals, many countries have placed emission goals to be limited to net zero by 2050. Well, in the next 50 years, we expect the world to have another billion people. So by about 2100, right now, we're going to have an additional 2 billion people. So we're trying to grapple today with emissions that are associated with 8 billion people. And over the next 100 years or so, we're going to have to deal with an additional 2 billion people on Earth. Now, where are these people going to be located? They're going to be in the developing countries of Southeast Asia, in India, and parts of Africa. None of the developing countries, certainly not Korea, not in the United States. Our populations may ebb and flow in the United States depending on immigration, et cetera. But the growth in populations are going to come in these countries that need energy. They need to increase their energy use. So our goals, as policymakers, as global stewards of energy resources, it is to look at how it is that we can provide the energy for these next 2 billion people in these countries that currently do not have adequate supplies of electricity or energy. And so that's what you have to consider when you're looking overall about addressing emissions. And when you further break down the population levels, 85% of the global population lives in these developing countries. So you can see the challenge is figuring out efficient energy systems in a way that does not require these developing countries to go through the same uses of energy that most of the developed countries have. And I'll get to that in just a minute. Now, the other, to me, fascinating change that we see right before our eyes, and we might not even know that it's happening, is that the global GDP is 2/3 of it is the services sector. Think about that. That's not manufacturing things, okay? That's services. That's people using transportation, using energy to do services and not necessarily even making things that people need. That's 2/3 of global GDP. Now, when you say, well, what about manufacturing? Well, 1/3 of the world's GDP is manufacturing. In guess which country does now 1/3, almost, it's approaching a little more than that. China does most of per country manufacturing. Now, well, how did that happen, right? Well, through most of my professional career, the goal of spreading democracy and encouraging developing capital markets and freedoms associated with democracy and free capital systems, it's been globalization. It's been intentionally designed in a way that countries like the US, outsource their manufacturing base to other countries. It was really by design. The hope was that you would open up China by, frankly, allowing them, if you will, to serve as a manufacturing base. When you look at civilizations through the development of time, you always see that typically developing countries are those where you will place manufacturing and energy-intensive industries at a lower cost because the cost of labor typically is cheaper. And so the cost of labor is one of the key elements in competitive pricing globally. And so we design these global markets. Of course, Korea benefited from this. So I think everyone knows, what I'm talking about. But when you stop and look at where we are today and where we're going and what we're trying to do with global security and increasing global energy supplies and developing these countries and meeting net zero goals, this is where we are today. Now, so with that backdrop, we then look to see about where are we with respect to energy demand and the sources of energy. Now, you've heard that we're in an energy transition. Okay? Energy transition. The energy transition from fossil-based to renewable energy-based, or from emissions-based to non-emissions-based transition. Well, the fact is we have always been in an energy transition. Back in 1924, one of the reasons for establishing USEA, or the World Energy Council, was the expectation that petroleum, this new fuel that really was going to be accessible and affordable, was going to drive out the use of biomass, which was supposed to be replaced by coal. So that was the big transition then. Well, I don't know if you've been keeping track of these figures, but last year, the world used more coal than it has ever used before. The world has used more oil than it has ever used before. The world certainly has set records for use of renewable energy and all different types of new fuels, biofuels, record amounts to meet the increased demand. But these are additives to the things that we currently have. So this transition that we're talking about it may be ongoing, and you will see studies. The International Energy Administration talks about in terms of, well, it may be that it's record amounts that we're using, but we're going to peak use soon. And so the predictions are, well, when are we going to peak, have peak use for these fossil fuels? EIA is very optimistic that that peak is going to occur probably in the next decade. Okay, that's the International Energy Administration. If you look at what OPEC believes, OPEC doesn't see that. OPEC countries say, well, it's probably going to continue to increase beyond the dates that IEA says. So my point on this is that you read a lot about the energy transition. You see a lot of new technologies coming on. You see incredible efforts to reduce emissions, and they are occurring. And yet our emissions continue to increase, and our energy demand continues to increase. So this is what policymakers have to deal with on this. And at USEA, we believe that as these I'll get to the next, I want to probably just go to the next slide here. Yeah, so what we see and what is happening is this enormous demand for increase in electricity. And let me pause right here to make sure that everybody has sort of a concept of, what our energy demands are. And so it's typically, you will hear the power sector. The power sector is the electricity sector. So much of our industries, our commercial businesses, our homes, our classrooms all use electricity. And so we typically have to use a fuel to create heat, to typically create steam, to turn a turbine, to create electromagnetic force, to get into the wires, to have electricity. So that's the power sector. So when you hear renewable use in the power sector, where that's wind, that's solar, these are non-fossil sources that can create electricity. And then you have transportation. Transportation typically is, you hear a lot about EVs, electric vehicles. Historically, that's liquid petroleum products. So that's gasoline and diesel, for example. And so you can have renewable diesel, you can have biofuels, you can even have hydrogen, you can have compressed natural gas, renewable natural gas. These are transportation fuels. In the United States, we have been so successful in replacing coal plants with renewables and natural gas that we have really driven our actual emissions down to below 2005 levels, actual emissions down. But that's primarily in the power sector. And the transportation sector now is the leading industry of emissions in the United States. It has taken the place of the power sector. So that's one thing you look at in countries where you say, well, how is it that we can reduce emissions? So you look at the power sector, and then you look at the transportation sector. And then finally, you have, the industrial or commercial sector. And here, again, you have thermal heat processes. A lot of the products in manufacturing that we make, take intense heat or pressure. Typically, this can either be done by fossil fuel generation or electricity. And then you look to see, well, what types of fuels am I using to create that electricity for the industrial processes? And that's where you can help reduce emissions. The other area is energy efficiency. You typically can do things more efficient with the use of electricity than you can with natural gas. So as an example, your electric vehicle. Your electric vehicle, if you notice, when you accelerate it, it's instant, it's immediate, there's no kind of surge. An internal combustion engine has sort of that slight hesitation when it takes out. That's energy inefficiency. That's the difference between the efficient use of electricity as opposed to an internal combustion engine. Early studies back in the 2017, when studies were initially written about whether or not countries like the United States could get to net zero, it was if you were able to electrify more of your transportation sector and more of your industrial and commercial sector, because of the efficiencies in the use of electricity over internal combustion engines, you needed less overall energy. And so as a consequence, you could reduce emissions more by moving toward electricity. So, that's what policymakers should think about when you look at choices. The other thing to think about too is on use of fossil fuels. So if fossil fuels are not going to go away as soon as some had hoped or predicted, focusing on emissions, it's, well, what can you do about that? Well, we have technologies today that if you can capture the CO2 and other emissions from the combustion of fossil fuels. That's carbon capture technologies. You can capture it, you can liquefy it, you can transport it, you can store it permanently deep in geologic formations. And you can develop, and we have technologies now for direct air capture. So direct air capture, whereas carbon capture and sequestration is typically on a point source of emissions. So think of a smokestack or think of a flue gas where you can put capture technology, say on the chimney itself, you can capture a lot of the CO2 there. Direct air capture is devices that are designed to have reverse fans literally pull air, just ambient air, through either a chemical process or a separation process, and you capture CO2 directly from the air. And then you can either store it, or you can use the CO2 to either put it into cement or other products, carbon products that you pull and sequester permanently from the atmosphere, the CO2. So those are some of the technologies that we have today. EVs, I put a slide here on EVs. These were the projections as to where we were headed on electric vehicles. And to be sure, we are certainly increasing the use of electric vehicles, but there have been recent announcements to where the increase is not going as rapidly as some of the equipment manufacturers had hoped. And in the U.S., there have been some recent announcements to slow down the expansion of building the facilities to make additional EVs. So this is where we are right now with EVs. More and more people are using them, however, probably not at the pace that might have been anticipated. Now, as we go to these new technologies, one of the technologies I did not mention, but I should mention here, is long duration storage for batteries. These are large batteries that can be placed on the electric grid to help serve two purposes. One as backup generation, if you will, that can be used when, say, intermittent resources like wind and solar is not generating electricity. And it can also be used to actually provide power, both for the ramping and power when it's needed. The technologies have been developing. They continue to be developed. We certainly have battery technology that can be deployed for 2 hours before it needs to be recharged. We have some now that we've developed that can run for longer, like 11 hours or 12 hours. In the state of California, the amount of battery use has increased significantly to where the grid operators no longer need to shed load. They can draw on batteries. And so this is another exciting area. Well, with battery, as you know, and with all these, this increase in energy demands, you need critical minerals. And you've read a lot about that. The United States studied this situation several years ago. Back during the Trump administration, they continued during the Biden administration. And the realization is that many of the developed countries rely on other countries for their critical minerals and materials. Coming out of COVID, most governments realized, should that be a good policy to be so reliant on other countries for materials that you need for your basic things? And so there's been a reassessment and a big move to have countries that can develop either the minerals themselves or to process them in the country so that they can be available to your to reshore your manufacturing processes so that countries are no longer dependent on other countries for these valuable services. And we see projections about the demand for these critical minerals that countries, the United States and others, are looking to figure out ways to develop their own sources, not just produce the product if they can, process the product, and then manufacture the products that are used. So this issue is an international one. There's only so many countries that produce these critical minerals, and it is changing geopolitics and relationships between countries. So this is another area where if you're in the energy space, if you care about climate change and the use of new technologies to replace some of the older technologies that we have, developed countries should figure out a way to make sure that they have access to these critical minerals and materials. Now, I talked about the need for innovation, and to be sure, you see the positive news, of course, is that we see across the world the increase in the electricity space and the power space, increased use in renewables, increased use in batteries, increased use in the transportation sector. But again, we see increased use of the traditional as well for the reasons that I talked about earlier. So this is actually very good news. Now, one thing that has happened that needs to be mentioned is that the United States just over the last 20 years did a couple of things. One, there was new technology that developed in hydraulic fracturing that increased the technology used for buffering hydraulic fracturing. Now, hydraulic fracturing is you drill into porous rock that contains either or both natural gas molecules and oil molecules. And through the development of multi-directional drilling and increased buffering technologies in the United States was able to drill and produce an abundance, really, of natural gas. And when scientists and engineers figured out that you could also frack an oil molecule, then the United States just has become the world's leading producer of both oil and natural gas, more than any other Mideast country, any other country in the world. Now, what is the consequence of that? Well, the abundance was so much that the United States now is the leading exporter of natural gas and is a and is one of the leading exporters of oil. It's not the leader in oil exports, but its 3, 4, 5 million barrels per day that it can export has served to counter the practices of the OPEC countries to be able to reduce production or increase production, whichever way they want, but can balance so that we don't have we being the global countries globally do not see $120 barrels of oil per day that you saw in the past before the United States was a producer and a leading producer and an exporter. So it balances now. Now that's great for two reasons, right? One, global prosperity. You're able to now essentially be able to purchase the oil and natural gas that you need on global markets. And the global natural gas markets have developed so quickly that they now look an awful lot like the global oil markets. It's that liquid. If you can put product, quote, on the water, then it can trade anywhere. We saw that with the invasion of Ukraine. Almost instantly, product that was headed toward Asia was redirected to Europe. And Europe became the #1 destination for a lot of the US LNG, even though it was Asia companies and countries that were some of the early developers and investors in US LNG in anticipation that the market was going to be Asia and that Asia would no longer have to pay the Mideast premium that it takes to get Mideast oil and natural gas to serve your economies. So that will continue. We see that. We see that both, that's a good thing for global prosperity. It's also important for global security. If we've learned anything as a consequence of the invasion of the Ukraine, is that you cannot depend on Russia pipeline gas in Europe. Europe has to break its dependency on Russia pipeline gas, and they look to the United States to be able to do that. But all countries now realize that you need a dependable and reliable source of energy, and Europeans and others have turned away from Russia. The current pledges are that that will remain in place permanently. And so as a consequence, it'll be the United States. The Middle East too is developing new sources of export, but the world typically looked to the United States as the source of increased production to take care of increased need in the future. And that has really become more evident with the invasion of the Ukraine by Russia. And so these are graphs that essentially show that is in fact taking place. So U.S. natural gas exports continue to increase. You can see the curtailment of the Russia pipeline gas. And so you can expect that this will continue in the foreseeable future. I also wanted to talk to you about nuclear power. The short story, on nuclear power was that it was being developed, certainly in the United States and most of the world, as a emission-free source of energy. It was going to replace coal. It was going to replace fossil. And things were moving in that direction in the power sector until 3 Mile Island occurred in the United States. That then caused a re-engineering of the whole process. There were new safety standards put in. It generally caused the price of nuclear power around the world to become more expensive. And with tight natural gas supplies, coal had a big resurgency of use. Then with the focus on climate change and emissions, once again, there was a rebirth of nuclear in earnest. There were plants being built around the world, and then Fukushima happened. So then that started, again, a stoppage. It started a stoppage, if you will, of nuclear development, again, increased expenses, and in the US and Europe and other countries, of course, Japan, they were focusing on no longer relicensing and decommissioning. And so it took a while. Well, then we had, again, another really push for emission-free electricity. We had the development of potentially new technologies, something other than pressurized water reactors or light water reactors. We had sodium-cooled advanced reactors. We had pebble bed reactor designs, and so there was a lot of movement in increasing accident-tolerant fuels, it's called, and so there's been a resurgence. And I know different countries take different views generally about nuclear energy, but what we are seeing is that China and Russia have really been going around the world selling, their nuclear technology and offering their nuclear technology, I should say, to developing countries and to other countries that are looking to have increased sources in their power sector and not want to go the route of fossil energy necessarily. They would like to get, nuclear technology. Well, in the United States, as you know, you might know, the Atomic Energy Act requires 123 agreements with all countries before U.S. nuclear technology can be used in those countries. Well, that takes a process, and not all countries want to go through that. But China and Russia do not have such requirements. While many of the countries are signatories to the Non-Proliferation Treaty, the United States 123 agreement requires countries to agree for non-proliferation and non-weaponization. There is an international treaty, but the enforcement of it is somewhat kind of remains to be seen. Well, China and Russia do not have this. Now, I go through all this to tell you that from USEA's point of view, I can say that it is a position on that, is that the OECD countries, the democracies of the world, should be the ones that maintain the intellectual property, the intellectual superiority on the technology used in nuclear. And collectively, we should not cede this to Russia or China. They are investing a lot of money into it. And so it's important that I think democracies work together to make sure that they can figure out ways to where countries are willing to build nuclear for civil purposes, for electricity, then we should collectively work together for that. Because if we don't, you will see countries that are desperate for electricity for their people, they will end up doing deals with the Russians and the Chinese. And that's just something you should be aware of. Not everybody has a favorable view of nuclear, but when you look at it in that sense of global security and you want to control potential threats of the use of the nuclear technology, that's where you need to have the agreements in place by the democracies of the world, it seems to me. So I like to remind people of that. And you can see that China is really moving forward with installed nuclear capacity. Now, it's a good thing for China, but they are exporting that technology for other countries. So, Now, before I turn to some questions, there's been a lot of talk about Green New Deals, whether it's in Europe or the United States, and what impact, does this really have? Is there a real impact or not? And there's hardly a day that goes by where you don't read an article in a leading international newspaper talking about both the exciting news about growth in new technologies, but also potentially what it's having with the existing economy. And one thing that we have seen here is, really the sort of the deindustrialization of Northern European countries. The EU has imposed, tight emission reductions. They have put in place an energy trading system. They have begun to put in place the carbon, cross-border, the carbon border adjustment mechanism, which will essentially put tariffs on products coming in based on their CO2 content. And so what we're seeing is industrial processes, some of them being closed in Germany. We see this, and it's being borne out here in some of the data that we're seeing. Now, I point this out because as policymakers, and you make decisions, it's easy to think that your policies will sort of balance out over time, and that where some industries may be impacted, it may be offset by the increase in new technologies. But it's a very different story in different countries. And in Germany right now is really having to deal with this. They, by many measures, and certainly since World War II, they were leading in the internal combustion automobile engines. And today, with the call for more and more EV uses or zero emission vehicles, China and other countries really are, China primarily, they build the most EVs, they build the most batteries. This is new technology, but it's not a technology that, say, the Germans have. So they literally are losing, their strength in their industries that they have really been world leading in many respects. And this is an impact right now in Germany. So they're reassessing some of the policies about this. Again, all new policies or change in policies will have to figure out are what we're doing, are we doing something to increase emissions, or are we doing something that can be part of a net zero, or are we doing something that actually reduces emissions? And so that's what you see today. That's what's different than just simply, policies that would drive economic development. Now you have this layer over of, well, we can do this. Let's look at a circular economy. Let's make sure that we're not creating problems for the next generation. Let's see if whatever we can do today puts the country in meeting its net zero goals. And so with that, I'll wrap up. And let me thank everybody for being here today. I hope you found it informative. I tried to make it somewhat enjoyable. And it really was an honor.